Star. This is the last day of Advent of Code. Merry Christmas, everybody. Joyeux Narwhal. As you can see, the Narwhal Christmas ornament on the left side of the screen here. I'm very disappointed that Eric did not put any narwhal jokes in. We had squids and whales and sunfish, but no narwhals. So I was just putting a little bit on Twitter. This is probably my most successful year using Advent of Code in a weirdo language that my history doesn't show. Because I think started using a different login, but I got 50 stars in Python and Swift and Rust, and then I switched to Haskell for 2018, and it broke my brain. In 2019, I used a graph grammar language that I wrote called Soffit, and only managed 7 stars. So that was a pretty poor showing. Last year, I used Pi, which is another dependently typed language like F star, and only got 14 stars. And this is really my best attempt at a really a non-standard language. Got about 2 minutes to go. Yesterday, I did not manage to get either stars. I think I was off on entirely the wrong track. I was viewing it as a programming languages problem of can I rewrite this into a form where it's simple, and probably I should, at least for part one, done simple search of. I looked at somebody's Rust solution. That's more or less what they did. So while I would like to decompile it or do a proof-based approach, probably just treating it as a search problem would at least get a single star there. And you can do that somewhat efficiently by searching for different values of the last, preserving all the state up until the last input and search all the values of that and then back up to the previous input. So I think that could be done pretty easily in F star. But I was trying something different, which was interesting. It's been a while since I did any programming language problem. I thought the search problem was too big as well, but then I was looking at somebody's Rust solution that they posted on Twitter, and it was just search. Liz Fong Jones of Honeycomb solved it on a spreadsheet. So that's one way to handle the decompilation is just solve it with pen and paper or spreadsheet rather than that's the reason I took the approach I did, is I thought the search space was too big as well, but it might not be. I made an attempt, and I only solved one problem, to use CUDA to solve Advent of Code problems, and the one I solved was one where we were breaking a hash function, doing a pre-image attack to find a password. Okay, one always moves east while the other moves south. Okay, so we've got another CA-like problem today. It wraps around. Interesting. So I get stuck. All right. Let's pull in the parts that we've used before. What was the last day we used our matrix on? Day 20. All right, so we've got, where did my mouse go? Well, I'm having technical difficulties here. All right, there's my mouse. All right. Buy a bargain basement KVM. You get a bargain basement KVM, I guess. All right, just a sec. Gonna reboot this guy. All right, better. So cell is empty, or a right facing one, or a down. I don't think we actually need the neighborhood today. We'll think about this. All right, we're probably gonna need our natural net range and our parser. So we'll copy that all out. All right, so there's our functions. Okay, so dot is empty. Let's call those east and south instead. All right. Damn it. I don't know why the interactive mode gets so upset. All right, we need. All right, looking good. So let's think about our transition rule. So during a single step, the east-facing herd moves first, then the south-facing herd moves. So can we rewrite this in terms of what happens to individual cells? I think it would be easiest to just write this as the east moves and then the south moves, rather than trying to deal with it simultaneously. Okay. So if we do that, then the transition function should be pretty easy, except we have to handle wraparound. So every place there's I have to handle this in 2 steps. So every place there's a dot and an east facing, the east facing is going to move. And then where there's an east facing and a dot, then that's going to transition to a dot. And we just need to wrap around. So let's change this to take, instead of this rule, we're going to take a transition function that is a function from y, which is a natural number less than width, and x, which is a natural number, that's less than height. X is a natural number less than width, and that returns a new cell. And we don't need this default value crap. Oh, I'm editing the wrong day. All right, let me revert that. Oops. All right, there we go. All right, does that type check? It does. All right. So let's write Okay, the transition function needs the matrix as well, which is why it's split out, capturing the neighborhood into a separate thing before. All right, still type checks. All right. Okay, let's do something fancy here. So we want to, for the eastward transition, we're dependent on R value and the one to the right, and nothing. No, that's only the case in one of them. So we'll keep it broken up. All right. So it could be empty, it could be east, or it could be south. If it's a south, it's going to stay pointing south. So if it's empty, then we need to look at the value to the west. And we can just take that mod, x west, we can take that mod width, and then we have to appeal to the lemma that says it's not the right lemma. Let me look it up. Oops. I don't have this set up in the right way. F star ulib. All right. Math lemmas. What does it say about mod? No. No. Mod less than 0 less than a. All right. Lemma mod less than. I'm not actually sure we need this, but we'll be conservative. Oh, yikes. We need to know that the width is greater than 1. Is greater than is a positive value, which we didn't tell it here. Oh no, that's implicit in that it's a matrix. So the matrix implies that constraint. So the implicit variables obey it too. Okay. So match value at my x west. Wrap parentheses around all this. So So if that is an eastbound one, then we will be east. Otherwise, we're going to stay empty. All right, does that type check? It does. All right. So for east, we're going to just do the opposite of that. We're going to wrap around. If that is empty, then we become empty. Otherwise, we're stuck. All right. And then it'd be nice to have some fancy higher order way to say, well, do the same thing but swap X and Y. I'm not that clever at 11:20 at night after celebrating Christmas Eve, so let's just all right. So it's empty. Then we look to the north. I did this wrong. Y north. All right. So if the value is a south, then we become a south. Otherwise, it stay empty. The nice thing about the strong type checks is, if I was doing this in Python and I missed swapping one X to Y, then it wouldn't complain until I fixed it. But here, because X and Y have different types, it's a lot harder for me to do that. It will say, oh, that's not the right type. You said X coordinates had this bound and Y coordinates had this other bound, and you haven't proven that they're the same. So there we go. So let's try this out. What else do we need? So we got our parser. We need our main function. We're gonna need more than that. Let's print it out. All right. So if it's a empty, it's a dot. If it's an east, it's a. I feel like we should be using fancy Unicode characters and ASCII, but all right. Don't need this rule anymore. Parse the matrix. Control Z is too close to Control X. All right. The thing we haven't done is computed did everybody stop. So the other piece we need is matrix equality. Um, so we could track it here, but let's just do the all right, so two matrices of the same size are equal if uh, for all for all I really want to zip them. Does zip work the same way? Oh, that's right. Do we only have ran into this before? We only have list, we only have zip on with an ML effect, not with a total effect. And the reason I think I decided I mean, this is just silly. All right, let's write zip. So we need the list to be of equal length. All right. So this returns, all right, so this is a total function, returns a list of A comma B pairs. All right, I mean, this should be good. This isn't too hard. I don't know why we don't have this in the. All right. All right, so we want to do something with the rows, and it's going to zip M1 and M2. All right, so for each of the rows, we're going to do a list, do a for all on the cells. Oh, no, there's a pair. So first C1 equals second C1, and we do that on the zip of the first row and the second row in the pair. All right. It's a nice little. All right, we have to be more specific about the type. This is a list of cell of list of cell. Oh, it's a list of. Okay, it's a pair. The first element is a list of cell of length W, and the second one is a list of the same length. Okay, that worked. I thought I was going to have to put in more parentheses, but I did not. So, all right, so there's matrix equality. We got matrix printing. Let's all right, let's write the I'm torn between just solving and seeing if it works. So let's solve it. I should probably see whether one step works, but this won't be wasted work. Okay, so we're going to iterate until same. And we have to use the divergent because we have no way of guaranteeing that this will actually happen, right? There are plenty of matrices where it won't happen, that it'll ever stop. I'm going to actually do ML so we can print out each one as we do it. So, all right, so let next n equals n plus 1. Let next, let's m1 equals, so first, uh, first east and then south. All right. So east transition. I need to give the matrix first. Okay. All right. Oh no, what's wrong? Solve the example, but there's some complexity in the the input not anticipated by the example, perhaps. Sorry to hear it. All right. All right. So if, all right, let's be careful we don't introduce an off by one. We want, what is the first step on which no cucumbers move? So if M2 is equal to M, then that's this step, not the previous step. That is when we reached our final configuration, but we want the first step in which they don't move. All right, so if return otherwise, we gotta iterate. M2 and next N. Confused the interactive session. I should go through and count how many times I do this. Oh, because I left this function unwritten. All right, so we just want to iterate until same M0. Not N, but nat. Oh, board. Oh, let result. We don't need it. We can just print it here. All okay, so let's copy the input. That's very large. All right, and the example. All right, and we actually have to run it. All right, let's give it a try. Well, that is definitely not working. So let's take a look at the first. Oops. Well, that is just completely wrong. All right. Well, it's not a subtle problem. Let's just make sure we're Let's just make sure we're parsing correctly, though I don't believe that's the problem. But the population's not staying the same. Like where did this guy come from? That's not okay. So I wish the matrix is not so hard to write test cases for. Um, all right, there is our problem. So let's write that as a lemma. Um, okay. East doesn't chain south. All right, so we require that value at m y x equals south ensures the value at east ensures east transition of myx also equals south. It fails because we're checking the wrong program. All right, so does this actually catch? This one catch the error because I made it in the wrong place. I made it here. Um, and so that says we don't. That's a little more subtle. Doesn't change. So this says if it wasn't south before, it if it wasn't east before, it can't be east now. This should also be true. Uh, uh, not equal to. All right. And so if we reintroduce my bug, recheck the models, should fail. All right, good. Check the move being blocked in the. Huh. Interesting. All right, let's try this again. I see. Well, I'm not even getting that far yet. So now I'm not moving at all. And east should be able to. All right, south moved. All right, I should probably try some of these easier examples. So, like, why didn't that guy move? And he should be able to move too. Oh no, he can't move because he's initially blocked, and then this guy moves. Did I get these backwards? Congratulations. Awesome. All right, let's start even simpler. All right, we'll put those guys up there. We'll put copy this part below that. even everything out. Are these reversed? So we look at what is, yeah, we look at to the east. If that is empty, otherwise we're blocked. And we look at the west. If that was east, then we will become east, otherwise we'll stay empty. Something is definitely wrong there, but I don't know what it is or how to write a model to. Yeah, it's completely not working. So let's write a test case. I mean, we can just give it. I guess this is the way we can avoid writing particular, giving the whole matrix. We can just say, what do we want value at of the matrix to do? Just assume that value at 0, 8 equals east, and value at m09 equals empty, then transition to of 0, 9 should be east, and east transition of 0, 8 should be empty. All right, no wraparound. Syntax. Oh, there's the syntax error. All right. Okay, so if that works, it means I'm not there it is. I'm not passing it in at all. All right, so maybe that'll work better. That would explain why the east wasn't moving at all, because I was just moving south. All right. Great. Let's try the real example. That is a very common mistake for me to have made this month is I want to do two things. I forget to put the second in. All right. So that checks out. Looks okay. Let's try the real input. Probably don't want to print it out every time, although that's sort of nice and hypnotic. Let's give it a try. Hurrah! Okay. Need 5 more. Well, it was nice that we were able to reuse so much from previous days. Um, I think since I've got an early start tomorrow, I'm not going to work on. I'm not going to work on previous days. Uh, oh shoot! The problem occurred because I had to change my monitor. That the chat's not showing up in this stream preview. That is unfortunate. I had that happen. So Epsilon asks, "How's my admin of code going?" Pretty well. I mentioned on a Twitter thread that this was my best year using an experimental language. So I am 1, 2, 3, 4, 5 short this year, and I think I can close them all up. But oops, events. Last year I used Pi, which is also a dependently typed language. It's implemented in Racket, but it's a lot harder to use. It's a toy language, and it's like it doesn't have strings. You have to convert everything into a list of integers to do it. The year before that, I used a language of my own devising called Soffit, which is a graph grammar language. And so it was even harder to get anything done. The year before that, I used Haskell, and Haskell just kicked my butt. Uh, so, well, good luck with your. Oh, I want to look. I want to look at your code golf for for day 23. Oh, I see. All right. Well, Merry Christmas. As I was saying, I will probably stream some of my attempts to pick up the last 5 stars, but it'll be on a irregular schedule. So, Merry Christmas, all. I hope you've enjoyed my attempts to wrestle with this new language. I've had fun, and I will hopefully see you next year. Good night.